Okay, so good morning, everyone. For those who expected to see Gerard talking, because his name is on the and his face on the brochure, so he's right here. Sorry to disappoint you, but in case you want to meet him, then he's here. My name is Harel, and together with Brian, we'll talk about how to setting up monitoring for Java applications for the build, measure, and learn cycle. We're both senior program managers with Microsoft, and I want to start with just a show of hands. How many of you are in the business of developing, operating, marketing of software? I guess most of you. How many of you are using monitoring tools to measure the performance or the usage of your app? Okay, a bit less. And how many are using the data that is coming from this monitoring to fix bug or improve new features? Okay, so hopefully I can give you some ideas about how to do that. So we know that it's a tough world out there. We know that today the success of a business mostly relies on the success of its software. And we need to make sure that the software we deliver is able to keep our business moving faster. We know that things are changing rapidly. We have to introduce new features to attract people. We know that competition is fiercer. It's a lot easier now to copy business models and to do similar things. We all know the Uber and Get Taxi, pretty much similar services. And the time to market is key. So you want to be first, and you want to introduce new features before your competitors do. But you need to make sure that those features are working right. You need to make sure you're building the right things and in the right quality in order to keep your business running successfully. And for that, you need data-driven decision-making. And if there's not enough pressure, there's also one additional inconvenient truth, is that whenever your development team ships a product, it could be either shipping it to operations, to run it in production, or to the customer directly. Essentially, you're setting up a time bomb, and that time bomb will eventually explode because things will go wrong, right? It could be your software, it could be the infrastructure on top of which it's running, it could be network. But in any case, you have to be prepared that things will not work right. You cannot stay behind this wall and be oblivious to what happens in production. Okay, so you got to understand, get a good picture of how your software is being used, how your users are behaving when using your application, whether it's available or not, and you need all that information in order to answer all these questions, like, is your application crashing? How many users are impacted by an issue? What is the root cause of any issue? Is it loading fast enough? Is my server handling the load? So you got to be able to answer all these questions at all times and in real time, or at least near real time, in order to pick up on issues and make sure that your business is running successfully on top of its software. So I guess that sounds intimidating, right? But luckily, there's APM, Application Performance Management, that comes to the rescue. And so let's see how it helps you to build better applications and implement these learnings from how your software is behaving into the next cycles of development. So let's take a look at the modern application lifecycle. We know that it's a continuous cycle, and it's comprised from the planning phase, development and test, release, and then the monitoring and learning, and obviously goes running around. In the planning phase, this is where everything begins, right? So your project starts, either the project from scratch or the iteration, and then you do the planning, managing the work, tracking the progress. At this point in time, it's crucial that your prioritization of work is based on real data, not on top of hunches or just random surveys or talking to customers. You need to get real data coming from your production system to understand what's being used, what's not being used, where to invest next, what's not working. So you'll be able to incorporate that into the prioritization work. The next phase would be the development and testing. So this is where you start writing the code and doing testing and using test environment. And it's important that at this point in time, you'll see the same picture that eventually operations would see when your deployment is running, when your app is deployed. And you need that in order to pick up on issues, see if your software is misbehaving in a development environment. You need to be able to pick up on bugs early in the process while you're developing them. And it's an important thing to have this visibility as you go ahead and develop your project. Telemetry should not be an afterthought. it should be right in the process of developing new bits. So after testing and debugging and writing the code, you have to release that. So usually you use testing environments and do cloud load testing, and then it's on to production. And in this case, you got to have the ability to quickly detect, diagnose, and triage issues. So that means that you need to stay one step ahead of your customers. So if there's an issue in production, you have to know it before your customers are encountering it. We've been talking to a lot of customers that essentially are relying on their customers to call them and tell them that there's an issue. And I usually tell them that your customers are very generous because other customers would simply walk away. We know how easy it is today to just open, let's say, the App Store, search for an app. If it doesn't work or crash, you just simply remove it and then install the next one, right? It's so easy. And you as a software developer need to know if something is not working, why people are leaving, what makes people stay. So you have to have this notion, really good notion of how it's behaving once in the wild. So again, it's all about reducing the mean time to detect issues, diagnosing the root cause, and then triaging. Triaging means you have to make an informed decision whether it's a critical enough bug to wake the people at night. So all hands on deck to fix the issue, or if it can wait for the next day or for the first or the next iteration. So eventually you need this information to make these judgment calls. And lastly, you need to incorporate all that data that is coming from your monitoring system into, first of all, to resolving these issues. So when you've identified that there's an issue that you do need to solve, you need all the actionable and contextual information of how to debug it. If your logs are on the remote machines, or if you're not getting the right data about where the issue happened, for what type of users, in what geographies, in what desktops or browser types, then you'll have a really difficult job to locating the bug. So you need all that information to reduce the mean time to resolution. And obviously, all these learnings are feeding the next iteration. So again, we're going to the planning phase and then incorporating that data into the prioritization work of the next iteration. So to give an example of an application performance monitoring tool, I'm going to talk about Application Insights. That's a product I'm working on in Microsoft. So let's look at an example of an APM tool, how it helps to get these business decisions. So let's talk first, what is Application Insights? So essentially, it's a set of SDKs that are allowing you to monitor your app. Doesn't matter if it's a mobile app, a server app, a browser app, or even a desktop app. So we have an SDK for all these platforms, and your app can be running anywhere, essentially, on premises, in Azure Cloud, Google Cloud, Amazon Cloud, doesn't really matter. So we can collect rich telemetry from all these kind of application types wherever they are running. That telemetry goes into our endpoint in Azure. That's the only extent where Azure is really in the picture. So there's no dependency on Azure in whatsoever. So essentially, the telemetry arrives there. We process it and store it, so allowing you eventually to get these dashboards and curated views, giving you a 360 degrees view about your application. If it's available, how it's performing, all the usage patterns, rich slice and dice tools, and all the data index, so you can search it and build your own charts. So eventually, this will surface the data that you need in order to get those decisions that we've discussed about. So let's look at we're talking about a lot about telemetry. So let's take a look at what exactly is being collected. So right here on the left side, we can see a schematic view of an app. So you have the infrastructure on which the app is running. You have the application platform. Then you have your actual bits, which are connected to some dependencies like databases or web services and whatnot. And then eventually you have the UI, which could be running on a mobile application, desktop, browser, and your users using it. So the first thing we allow collecting to get us information about availability is outside-in monitoring, essentially ping tests. So you can set up tests from around 16 points of presence around the world, which will ping your site and will tell you if it's available or not and how fast it responds. It could be simple ping tests. It could be more complex web tests that you can construct of multiple steps, like do authentication, visit a couple of pages, and then see if you get the responses you want, if the site is available, and if the responses time are adequate. The other thing is observed user behavior, so understanding how your application is being used, how many users you have along the time, how many new users you're attracting, how you're retaining your existing customers, what pages they're viewing, what actions are they doing, how often did they come to your site. So you need to understand the traction in your site and how to retain users, what features are being used, so you'll know where to invest next. The other side of having this usage statistics is to analyze whenever you have issues, what's the impact. If a lot of people are being impacted, then you have a better notion that you need to fix it right away. If it's some esoteric feature that isn't really used, perhaps it can wait for the next day. On top of that, we also get a lot of things from the application platform. Things with no code required, like service dependencies, or if your code is calling databases, let's say Oracle DB, MySQL, it calls Redis cache, whatever. So we can track these dependencies automatically and tell you what dependency was called, how long it is taken to execute the operation, and whether it succeeded or not. So you can essentially inspect whether, if you have a bottleneck in the process, you can inspect whether that bottleneck stems from your code or from the dependency that you're calling to. And you can make a decision if you need to, let's say, build better indexes in the database. Other things we collect is response times from the application server, unhandled exceptions, log information. So we have appenders for log4j and logback that allows you to get automatically all your trace logs into our portal where everything is indexed and you can search on it. On top of all the things that are collected automatically, you have the ability to use our API to send custom data. So apart from getting the page view information and all the traces and stuff, if there are specific points in your logic that are important to you to track, so you can use the API to send custom events or metrics or exceptions, even if you catch them. So essentially, if you need to track important things in your system, like if a customer emptied the shopping cart or how many items he had in the shopping cart before checkout, then you can use the API to send your own data. And lastly, we also collect information about the infrastructure, so essentially performance counters and JMX counters that you can add and get a picture of how the device is running your app is behaving. So you hear me talking and probably you think, what's Microsoft has to do with it, right? With Java. So Microsoft loves Java. If you've been following Microsoft for the past couple of years, you'll notice that there was a big movement towards Java. We support Java as a first-class citizen in application insights. We have a native Java SDK. I'll talk about that in a minute. But essentially, Java is a first-class citizen. We support it like we support .NET. And Brian is going to talk next about the latest developments in the Microsoft and Java integration world. So what do we have for Java? So we have a native Java SDK that collects all the telemetry that I've been talking about. Doesn't matter if the app is running on Windows or Linux or Unix. So HTTP requests, performance counters, including JMX, unhandled exception, trace logs, and an API. Supports all the popular application servers like Tomcat, Jetty, JBoss, etc. And the SDK is open source, of course. We have a Java agent that collects called dependencies from dependencies like Oracle DB, MySQL, SQL Server, HTTP resources, Redis cache, along with method execution times, handled exceptions. And to get started with application insights, it's really easy to just use the Eclipse plugin to just instrument the app, and we'll have an IntelliJ plugin coming soon. And lastly, if anyone is using collectd, anyone? Are you familiar with collectd? So essentially, it's a Unix daemon that collects various statistics from a machine. It has like over 90 plugins for reading data. So we also have a writer plugin for collectd that allows you to send these collected metrics into application insights. So with that, let's take a look at a demo of application insights and see how it helps us to get a better understanding of the software. Okay, so this is the Java Pet Store, probably familiar with that. So we've instrumented that with the Java SDK. I've been talking too much, so the session expired in the meantime. Okay, so this is the new Azure portal. And what I'm looking at now is the application insights resource to which I'm sending all the telemetry from the Java Pet Store. I see that we have various telemetry types collected for that Java application. Since there's not much traffic to this site, let me just open up another application that I'm monitoring. It's called Fabricam Prod. So this essentially is the overview blade. The overview blade give you a picture of your application health at one glance. So you see server response times over the past 24 hours. You can obviously change the time range you're looking at, along with data from the client, so browser page load time, along with server requests and fail requests. So you can see on a single timeline whether there's any correlation between issues. Let's say with server response time, if it correlates to the number of requests you had and how many fail requests resulted from that. Everything, of course, is drillable. So you can drill into the server response time to view more information about it. So you see, again, the server response time together with the information last week. So you can see that as opposed to last week, we're actually improving. So you can see the trends on how your application is behaving. You have here the dependency calls. So you can see also the performance of your dependencies. So again, calls made to databases and stuff. You have a full breakdown of the response time by operation. So I see that there's a get operation for reports, for an employee report. I see that it's taken a lot more time. I can drill into that to see more details about it. So I see how many time I see the response time, how many time it had failed. I see all the instances, and essentially I can see that we have some. These calls resulted in server error 500. So I can drill further to see what's the issue with that. So I can see the exact request, from which machine, from which client IP address, the full request URL. I can see all the dependencies that were called during this operation, so various calls to SQL databases. And then I can also see the exception that was thrown as part of handling this request. So I can drill into that and essentially see that it's a system null reference exception resulting from object reference not sent to an instance of an object, the infamous error code. And I can see the full stack, the full call stack together with the lines of code, line numbers. I can show all the call stack, or just the information coming from all the frames coming from my namespaces. And obviously you can see all the related items. So all the telemetry for this user session. So all the things that the user has done before the application crashed, or all telemetry 5 minutes before and after this event. So this is especially helpful for tackling these nasty bugs where it happened only in a very specific flow, and it's really hard to reproduce that. So once you have all this data, you can see essentially all the things that led to the exceptions. You can see exactly all the steps that happened and what happened, where the user navigated from, what he has done in each of the steps, in terms of page views, dependencies that were called, traces that were collected. So that helps you understand what is the root cause. Another thing, so we've looked at some server-side statistics. We also have some browser page load times, and that gives you an understanding what is happening on the client side. So essentially, we give you a full breakdown of the page load time. We'll say that in a second once it's loading. So you'll see in a second all the steps in rendering the page. So receiving the response from the server, rendering the page. It will load in a second, or not. Browser exceptions, along with page views. Yeah, sure. There it goes. Yeah, so essentially there's an SDK that there are two options essentially. One, if you have access to your code, you just add our SDK and it automatically collects a lot of information. So that means that you need to recompile your project. We will also have an offering if your application is already live and you don't have access to the code or don't want to touch the code. We also have some offering for getting information from the outside. So that's also possible. So if you don't want to touch the code, it's fine. The only difference is that when you're compiled with our SDK, you can also send custom events. And we'll see that in a second. So yeah, so here we'll see a full breakdown of the page. So I can see whether the pages are loading correctly or if they have any browser exceptions, etc. And we've looked at server requests and file requests to see all the information that is coming. We can see that, all the requests that ended up in response codes, like all the 400s, 500s, which dependency calls failed, and how long it is taken to execute those, and essentially get all this information. I also mentioned earlier that it's really important to check the availability of your site to make sure that it's responding, that it's alive, and responding well. So you can set up web tests, as I said, where you set up either a URL ping test or a multi-step test. I have some noisy neighbors on my subscriptions. So let's move that. So essentially, you can provide a URL. You can specify how often to test your site with these ping tests. You can specify all the locations around the world to test this site. We can see that now it's running every 5 minutes from Chicago, San Jose, San Antonio, and we have in Stockholm, Amsterdam. And then you can specify what counts as a success for the test. So you either expect HTTP response with a status code 200, or you expect a specific content to come back. And you can specify the threshold for getting the alert. So if a specific number of locations return a failure within a specific time window, let's say the last 5 minutes or 10 minutes, then it's all possible to configure. So with that, you get an alert, and you can decide whether you want to wake up the team at night or not. You have performance counters, as I mentioned earlier, coming from the servers with a breakdown of the exact servers running your code, process CPU, memory, etc. And you also have some usage information, which is especially useful. So let's take a look at that. So you can see how many users you had. Here we're talking about 24 hours, but you can, of course, change the time range. And you see how many of those were new users. So again, how you're attracting new users and how are you retaining existing ones, what geographies they're coming from, all the sessions that they have initiated, essentially. So you see things like how many sessions these users, so how often they return to your application, the time between sessions. So we see that people come back once every 13 days, which isn't a lot. I guess if it was Facebook, probably would have been like 3 times an hour or every 20 minutes. So this gives you an indication of how often people come visit your website. Of course, you can see the operating system they're coming from, what pages they're viewing. So a full breakdown of the pages. Again, if you have a specific issue in a specific page, you can see which page should be fixed, how many visits it has, what's the entry and exit pages. Entry and exit pages give you an indication what's the path that users are doing in your app. So if you were an e-commerce site, you would expect people to come in the home page or the search page and leave in the checkout page. So you can essentially substantiate that by looking at these figures and see that if indeed people are leaving at the checkout page, but if they're if they're leaving at the search page, that means that your search didn't yield the right result. Or if they're leaving at the error page, then obviously you have an error that you need to fix because people cannot complete their transactions. And lastly, you have the custom events that you can send. Again, if you have specific occurrences that you want to track, like someone made a transaction, started a transaction, completed a transaction, you can send that and also show a funnel of that. So how many people browsed an item, started a transaction, versus how the number of transactions being completed. So we see that 350 transactions started, but only 200 of them completed. and we see that there was a timeout for the remainder number of transactions. So that means that people started to do something but didn't have the motivation to complete the transaction. So again, that gives you the information if you need to go ahead and pop up some reminder or to do whatever you need to make those people pay money, right? It's all about essentially providing this value to our customers. And then you can also view the first custom event that was sent and the last one. So same as the exit and entry and exit pages, you can see what's the first thing that they've done and what's the last thing. So we can see that everybody starts with browsing an item, and again, the last thing they do, they're browsing an item. So they're always in the browsing phase, don't ever do any purchase, or most of them. So that's an indication that something is wrong. And lastly, all that we see here is all the data essentially can be exported. So you can set up continuous export of your data, just define the storage account to which you want to export it, and to tweak which telemetry types you want to get exported. So availability information or custom events or exceptions. And once this data lands up in your storage account, you can take it to SQL database or Oracle database and do whatever calculations and reports on that. You can use machine learning. You can take that to merge with your business data to do mashups. So essentially, you have you have the information, everything is open, so you can take it and do whatever telemetry scenarios you need. So this is a quick tour of application insights, and we can see throughout these various hubs that we've seen how you can essentially how you can understand how your users are behaving, how your system is behaving. I mentioned earlier that we have a powerful search capability to search on whatever data you want, or ability to explore metrics and build your own reports. Let me just show an example of that, the last example. Yeah, so essentially here, let me do that from blank. I want to show you how it's done. So let me remove this chart. Essentially, Metric Explorer is a blank canvas for you to build your own reports on. So I cleared it up. Let me just add a chart. I can select what metric I want to display. There it goes. I'm clicking too fast. So I can see all the metrics that are being sent, client-side metrics, server-side availability metrics, performance counters, whatever. So I can draw whatever I want. So let's take a look at exceptions maybe. And I can make that bigger. I can decide I want to see that bar, grade, area. I can turn on prior week to see the number of exceptions in the previous period. And I can also turn on grouping. So I can see like exception based on various dimensions like, let's say country or region. So I can see that most of the exceptions are happening in the United States and Germany and only one in Ireland. So if that exception maybe is related to localization, I can decide that, well, the Irish people could wait for another day or two. And I can also add, no offense, right? And then I can add some additional metrics to correspond with the other things, like if I want to see, let's say, process CPU, to see if that caused an exception. Let's group that again. So I can correlate between exceptions and process CPU the minute it loads to see if there's any relation between them. So that's a quick tour of application insights. Again, an example of how an APM product can help you. If you'd like to give it a try, then it's available in free and standard and premium tiers. So essentially, you can get started for free, up to 5 million data points a month. That's a free offering. The main differentiation is on data volume, retention period. And so essentially, you're welcome to get started. Here's the link. We'll also show you how to get to our booth in case you'd like more information. And with that.
So that's a bit of a giveaway about what I was going to
Yeah, so obviously no magic, right? Because we're doing work, but keeping a low footprint is something that is one of our key goals. Our goal is not to incur more than 1% of overhead. So if your server is handling 1,000 requests per second, let's say, you'll still be able to process 999 per second at the worst, right? All the data that is being collected is buffered, compressed, and then sent asynchronously. So it doesn't interfere with your app. It cannot crash your app. So yeah.
It doesn't use VM resources, right? Your actual VM itself running, it uses enough to generate the data, but the data is elsewhere.
Yeah.
Right? It's in a different location. So yeah. So I wanted to talk to you about some big news that we have. How many people here are working with Azure at all right now? A few? Good, okay. Linux on Azure, I assume? Yeah, okay. So if you're working with Linux on Azure, you probably know, if those of you who don't know, we have 4 flavors of Linux that we support on virtual machines. We have CentOS, SUSE, OpenSUSE, Ubuntu, and actually we have the 5th of the 4 is Oracle Linux as well. These are all supported and they run. Red Hat has been something that we've been working with. The legal team's been working with Red Hat for a while now. The technical details were worked out a long time ago, but now we actually have, yay, Red Hat is fully supported on Azure. So if you're using one of those flavors of Linux, just in case you don't know, 25% of our VMs on Azure are actually Linux. We don't know a lot about what people are running in their VMs just because we don't want to. It's not our business model to get in and analyze people's data. But one of the things we can find out is how many people are running Windows, and then we assume people who aren't running Windows are running Linux. And there's 25, 26% who aren't running Windows. They're actually running Linux on our VMs. And it's great business for us. We love working with Linux. And Red Hat was the only one. I was just at Java One last week talking to a bunch of partners and things. All of them said, well, our products first and foremost run on Red Hat Enterprise Linux. And I had to sort of bow my head and say, oh, why couldn't we get this announcement last week? But anyway, it's out there now. And if you want to just go to the next slide. Thanks. So what does that mean? We've joined the Red Hat Certified Cloud and Service Provider. We filled out the form and everything. And we have a whole team now who is actually going to be supporting Red Hat on Azure. And they're co-located in Redmond. We have Enterprise Linux and JBoss. We are working with them right now to build some customer environments, some pay-as-you-go things. And we're going to work with CloudForms and some of our virtual machine managers as well to integrate the systems management. And our hybrid story is going to be great with this. If you have Red Hat running on-premise or in a cloud, it doesn't matter. We're going to be able to run both and integrate with both with our systems tools for Microsoft and for Linux. It's pretty cool. And of course, those of you, I'm sure this whole crowd would love to know about our .NET integration, but that's actually working as well. If you want to just go to the next slide. So there's a couple things. In the next few weeks, we're going to have our team set up to support this. As of today, you can put Red Hat Enterprise Linux on virtual machines on Azure. It's supported. It runs. And we're going to have subscriptions. We're going to be actually bring your own license subscriptions to Azure. But if you want to go to the next slide as well. Thanks. And then later on, we're going to have a pay-as-you-go version of this. And what that means is you're going to have a Red Hat Linux pay-as-you-go image. If you need an image for 3 weeks, you can go out, set up a virtual machine, and you're only billed for the 3 weeks for the license and for the virtual machine usage all together in a pay-as-you-go bundle. And as I mentioned, CloudForms and system-centered virtual machine managers are going to be integrated as well. And we're working on some container technologies that will be integrated too. So exciting news for us. The last piece of the Linux puzzle for us was the Red Hat Enterprise Linux. So I'm glad we have that going. Hey, one thing I wanted to mention, Harel's probably going to mention it anyway, but we're here to get feedback from the Java community about the tools and technologies that we have and how we can actually make them better. for the Java community. We have SDKs and IntelliJ plugins and Eclipse plugins. When we have a survey, if you want to come by our booth, we have a survey that we'd like you to fill out if you could, and just indicate at the end of the survey if you'd like us to follow up with you. And we'd like to work with you to build the next version of our Java tools and technologies. And in thanks for filling out the survey, we'll give you one of these speakers. So thanks. We'll hand it back. Thank you.
Yeah, so let's open it up for questions, if you have any. Okay.
Huh.
Do you want to mention the other things we have for Java in Azure?
Yeah, sure. We have actually a number of things. I don't know if my browser's not working. The internet wasn't very good there. But, oh, you've got a hardwired connection.
Yeah.
Let me show you some of the stuff we have. How much time do we have, by the way?
We have
15 minutes? Okay. I can just give you a little tour of what we do have. Java Azure. So one of the things we have here, this is our Java Developer Center. And we have a Java SDK. This SDK is written around our Azure services. And I don't know if you can see that there. Let me just zoom in a little. So the reference docs here, we actually have several services on Azure that you can access. And those can be accessed from an on-prem application or a cloud-based application. We have a blob service, just file system, document DB, which is our NoSQL offering. Media services is a good one. Now, if you're building media services into a Java application, quite often, you'll have to worry about streaming and scaling and encoding. Those are the three things you have to worry about. So our actual media services service allows you to upload a video, and that video can be encoded in dozens of different formats depending on the client that's trying to read it. It gets served up to those clients automatically, and you can scale however you want the streaming to be done as well. That's all built into the service. You pay one fee for that, and you can access that. I actually have an application that I wrote that uses most of the features of the SDK, and I have to remember where it is. I wasn't planning on doing this. GitHub, Azure Chat for Java. There it is. Okay, so Azure Chat for Java is an application. It's a Java application, and one of the pieces of feedback we got from customers is, oh great, so you have an SDK, you have all these facilities. I want to see it in action, and I don't just want a hello world application. I want an actual working application that runs and allows you to use all of these SDK features in one place, and I can borrow the code later and use it for my own applications. So that's what I did here. I built an application that uses access control service, SQL database, tables, storage, media services, queue storage, and service bus queues. And it actually runs, it looks like a social media application, much like Snapchat, and allows you to process pictures. You can do comments, you can do likes and things like that. But all of the instructions here on setting up the application and setting up all the services behind it are in the README in the GitHub repository. It takes about an hour to set up, and it's a great way to learn how to work with Azure services or services on the cloud in general, and then access those services from a Java application. For example, how do I actually write from a JSP to a blob service, get some data, and then display it on my screen? Get a picture displayed on my screen, things like that. That's what this application does. So getting back to the Dev Center, those are the different tools we have, and we've got that application for doing that. Note that the SDK runs on Windows, Mac, or Linux, and the source code is actually out on GitHub. So you can see it there, the Azure SDK for Java. And the SDK itself, actually we have tons of things on GitHub that you can use for this. The SDK itself is open source. You can use it to access things. You can take it, you can clone it, anything you want to do with GitHub in general. What else can I show you? So just in general, this is just one of the SDKs we have, actually. If you go to the Azure GitHub site, we have a number of SDKs for PHP, Linux. Let me see. Let me go there for a second. PHP, Python, Ruby, et cetera, et cetera. I'll go back to the Dev Center real quick. And where is downloads? You know what? Let me go Azure SDK. There we go. Azure SDKs and tools. So .NET, Java, Node, PHP, Python, Ruby. We have a mobile SDK as well and a media SDK. So that media services that I talked about, there's all kinds of ways to actually display things in desktop applications, mobile applications, et cetera, et cetera. We work with Android, iOS. We've got a whole bunch of things. If you're building Java applications, you want to take them to the next level, integrating with the cloud and actually build applications. This is one way to go. For deploying things out to Azure, we've actually created some other multi-platform tools. Windows, Mac, and Linux versions of our command line interface. And the command line interface itself allows you to deploy things out to Azure. Let me know when I'm running out of time. So I can deploy things out to Azure and with the CLI. Is anybody here familiar with VM Depot, which is one of our tools for Linux? Okay, so let me show you that. So we actually have a VM Depot. It's about 700 Linux images. They're all open source and they're all free. And you can actually deploy these out to Azure virtual machines. They're pre-packaged and ready to go. And we're doing a similar thing with Docker, by the way, with containers, with the Docker Hub. We're going through the Docker Hub slowly, testing all the containers they have there to see if they work on Azure and integrating them into our marketplace. But for now, VM Depot, for example, if I look for Tomcat, there's several different versions of tools that you can use. There's a basic Tomcat image. There's also a JRuby stack, and this is a good example because it has Tomcat, MySQL, JRuby, Rails. Everything's already integrated and working in a virtual machine that'll run in Azure really quickly. It's created by Bitnami, which is a reputable virtual machine image creator. So to deploy this, I just click here. I pick a region for Azure. Let's say I want to deploy my JRuby stack in Southeast Asia. I showed you the CLI a minute ago. This is what the CLI is good for. So the command line interface, this is actually the script that you would use. You can cut and paste this into a command window, add a few different things about your subscription, and deploy this out to an Azure virtual machine. You'll have it up and running in minutes, where it might take hours or even days if you don't know how to set up JRuby with MySQL and things like that. So it's all pre-configured and pre-made for you. Now, this is only going to create a single virtual machine on Azure. So what if you want to create a cluster on Azure? We have something called the Azure Resource Manager. Resource quick templates. So this uses a similar scripting to the Azure command line interface. It's all JSON based actually. And if I do a search on Tomcat here, there we go. So there's one, it's going to deploy a Ubuntu VM with OpenJDK and Tomcat. And this allows you to set up a cluster. So if you need to set up 40 Tomcat servers, put your applications on them, things like that, you can use this thing called the Azure Resource Manager. And you can start with this quick start template and deploy it out to Azure. I don't know if you're logged into Azure on this machine, but let's find out.
Yeah.
Yeah, okay, you are. All right, so this is what it's going to do. If I click there, it's going to go to the portal. I'll just select that. It actually goes, that's okay, never mind. I think I'm going to stop it there, but unless you want to, yeah, you can set up your ID. But anyway, so the idea is we have a lot of tools and technologies you can use. SDKs, I didn't actually get to the Eclipse plugins. We have Eclipse plugins and IntelliJ plugins for actually deploying things out to Azure Cloud Services as well. So we have our virtual machines. That's everything I showed you here. We also have cloud services, which are Windows-based. we manage the OS for you, and you can package things up and deliver it out to Azure as well. So here's the portal going. Any questions about any of this so far? Oh, okay, all right. Yeah, a lot of this is new stuff, I'm sure, for a lot of you, but there's a great, if you just search on Azure, just search on Java Azure, you're going to get to the Azure Dev Center, and it has a lot of information about how you can actually implement these things. And there's a lot of other options as well. So the actual template itself, you have your choice of JDK 6, 7, or 8, Tomcat 6, 7, or 8. You choose a location, you set up some storage accounts and things you need related to that to set up the Tomcat environment, and you can set up how many nodes you want in your cluster. And it's going to go out, it's going to create Ubuntu with Tomcat virtual machines, however many you need, and you can deliver those, put your application on them as well. So editing the template, this is what the template looks like behind the scenes. It's JSON. It's pretty easy to learn and figure out, but you can use one of our quick start templates and edit it to quickly and easily deliver these things however you need to, basically. And one of the cool things you can do is you can put something like Jenkins on here or Chef, and then once you have this army of Tomcat virtual machines, if you have Jenkins and or Chef on them, you can also use Jenkins Chef recipes to deploy and manage and run those machines as well. So just a few ideas there. There's more. Like I say, go to the Azure Java Dev Center. There's also a portal that Harel has for the ALM tools that we have for Java. And we also have some websites, tools, and a bunch of other things. But the Azure Java Dev Center has more details. And also stop by the booth and fill out that survey. And in thanks, we'll set you up with a speaker. The speaker comes with batteries and a plug-in and everything. It's all ready to go. So
yeah, the last thing I'll show is you mentioned the Azure SDK. So if I have a Java application straight from Eclipse, I can use install the Azure SDK and then configure application insights to send all the telemetry. So again, going back to the point of instrumenting your app and going to get all this telemetry. So that's how easy it is. Just click a button, log into Azure, and that's it. You get all information. So I want to thank you for your time, and if I have one ask for you is come visit our booth. Feel free to ask us more questions. Come pick up these speakers, and thank you.
Thanks.